Okay, so back in chapter 1, we did some graphing. We graphed some scatter plots. And then after we graphed some scatter plots, we grabbed a ruler and we tried to make a line that came close to our dots. What we're going to start to do here in chapter 3 is connect graphs to actual equations. So we're going to start with graphing one of the most simple types of equations, y equals mx plus b. All right, so I might give you an equation like y equals 2x plus 3. So that's in the form y equals mx plus b, where m here is the number 2, b is just the number 3. A solution to an equation with two variables is an ordered pair that makes the equation true. I might ask you, is 1, 5 a solution to our equation y equals 2x plus 3? And you would tell me yes or no. "50-50 chance of being right." Yes. Why do you say yes? You just plug the numbers in. This means x is the number 1, y is the number 5. If I plug 1 in for here, I get 2 times 1 plus 3, that is 5. So is it a solution? Yes, it worked. Give me another solution.
210.
210, okay. Is 2, 10 a solution? And this time I think you would say
No.
no. Why not? What's wrong with 2, 10?
11.
This equation, y equals 2x plus 3, still, I'm still using that equation. Is 2, 10 a solution to that equation? No, because what happens if I take x equals 2 and plug it in? What's 2 times 2? 4 plus 3? 7. Is 7 equal to 10? No. No. But 2, 7 is. How many solutions are there to that equation?
A lot.
How many is a lot? 10? Is 10 a lot? Or is it more than 10?
More than 10?
Are there more than 10?
Yeah.
Yeah, I think there's more than 10. How many answers are to that equation? Well, could I take x equals 3 and plug it in and get an answer? Yeah, if I were to plug 3 in, so let's see, more solutions to y equals 2x plus 3 are. If I were to plug in 3, what would my y value have to be? 9. So there's another answer. Could I plug in 4? Yeah, and I get 2 times 4 is 8. 8 plus 3 is 11. So how many answers are there going to be? An infinite number of answers. How come? X can be any number, can't it? And once x is a number, I'm going to get an answer for y. So how many answers are there? An infinite number of correct answers. So y equals 2x plus 3 has an infinite number of solutions. I'll move the thing here. Better?
Yeah.
Y equals 2x plus 3 has an infinite number of solutions. So how would you feel if I told you I want you to list all the answers to that equation?
Sad.
Sad. Why would you be sad?
We need it forever.
You can't do it, can you? It would take forever. You can't possibly list them all. So we don't try to list them all. Instead of trying to list them all, we give a picture of what they look like. So what do we call a picture? In math, we call it a graph. We can't possibly list all solutions. So rather, we draw a graph of the solutions. Here's what's typically going to happen. I'm going to ask you to graph y equals 2x plus 3. What you're going to do is you're going to build me a table and give me some solutions. How many should you give me?
5.
5, I think, would be a wonderful number if you were to give me 5 solutions. And once you have your 5 solutions, you'll draw those solutions on a graph. Okay, so you get to pick your 5 favorite numbers in the whole world and plug them in for x. Now, I would suggest when you pick your favorite 5 numbers in the world, I would suggest one of them that you always pick is the number 0. Why do I think you should always pick the number 0? Because it'll tell you what? You said the right thing. Which one, the x or the y? It will give you the y-intercept. If I plug in x equals 0, and I'm going to plug it in. So I'm going to have 2 times 0 plus 3. How much is 2 times 0? 0. 0 plus 3? So the other really nice thing about plugging in the number 0 is it's really easy to do. Because anything times 0 is 0, you just add. So that's always, if you plug in 0, that's always going to give you the y-intercept. And that's always a nice thing to have. Then I would probably suggest that you pick 2 positive numbers and 2 negative numbers. So tell me your favorite 2 positive numbers in the whole wide world.
6.
6 and 8. All right, now I would have gone with 1 and 2, but you guys like bigger numbers apparently, 6 and 8. I would have gone 1 and 2, but that's okay. Tell me your favorite 2 negative numbers in the whole wide world.
Negative 6.
Negative 6 and negative 1. Okay. Does it really make any difference which numbers we pick for x? No. Most students would go 0, and then they'd go 1 and 2, and then they'd go negative 1 and negative 2. Perfectly fine. If you don't like using 1 and 2, if you like 6 and 8, use 6 and 8. Use any numbers you like. It really doesn't matter. Now, of course, the bigger the numbers you plug in, the harder you make the arithmetic for yourself. But that's okay. We're good at arithmetic, right? We plug in 6. We've got 2 times 6 plus 3. What's 2 times 6? 12 plus 3. 15. All right, then we plug in 8. We have 2 times 8 plus 3. 2 times 8. 16 and 3. 19. Well, the other thing with plugging in bigger numbers, of course, you get bigger y answers. It's going to make your scaling a little harder when you go to draw your graph. But we'll be okay. We'll figure it out. Okay, then we plug in negative 6. Now we've got to be very careful with our minus signs. 2 times negative 6 plus 3. How much is 2 times negative 6?
Negative 12.
Negative 12. And then you have to add 3.
So
Nine.
negative 9.
Negative 9. That's right. You spent $12 and then somebody gave you 3. You're still $9 in the hole. That's negative 9. And finally, we plug in negative 1. 2 times negative 1 plus 3. 2 times negative 1. Negative 2 plus 3.
1.
Positive 1. Okay. When I go to draw my graph, I'm going to draw some tick marks on my x-axis here. How do I want to scale? Do I want to go 1, 2, 3, 4, 5? I think 1, 2, 3, 4, 5 would be okay. I think I'm going to go 2, 4, 6, 8, 10. Because because I didn't make enough little tick marks to go 1, 2, 3, 4, 5 to get all the way out to 8. I think I'm going to go by 2s. -2, -4, -6, -8. Okay, how about my y-axis? 1, 2, 3, 4, 5? 1, 2, 3, 4, 5 probably isn't a good idea. Why not? How high up do I have to go? I gotta get all the way to 19. I don't think I want to go 1, 2, 3, 4, 5.
3.
3s, 5s, 4s. I think any of those would be good answers. So I think I'll go 3, 6, 9, 12, 15, 18. I think 3s will be okay. So that's -3, -6, -9, -12. Now, what should happen? When you graph something of the form y equals mx plus b, your dots should always fall perfectly into a line. What happens if you draw some dots and they don't fall perfectly into a line?
You messed your formula up, your equations, your answers.
Either you messed up your arithmetic or you graphed it wrong. One or the other. Okay, so in this section, when you draw your dots better always be in a nice straight line. If they're not in a nice straight line, you made a mistake somewhere. Let's check. 0, 3. Where is 0, 3?
On the y-axis.
That's the y-intercept. It's right here, 0, 3. 6, 15. I start here, I go over 6, up to 15, right about there. So far, do they look like a nice straight line? Yeah, but of course that's a trick question, because if you draw 2 dots, they always look like a nice straight line. So 2 doesn't help. Let's try number 3. 8, 19. 8 is here. 19. So far, so good. They still look like a nice straight line. -6, -9. There's -6. There's -9 right there. Still looking good. And finally, -1, +1. Okay. Then what do we do?
Make a line.
You make a line, you play a game of connect the dots. So there's your answer. There's what the graph of y equals 2x plus 3 looks like. Questions on that? Okay, let's try another one. How about y equals -2x. I used 2 last time, didn't I? Let's use -3x. I'm just going to start all over. Y equals -3x plus 5. And again, the directions are going to be graph. We're going to build ourselves a nice little table here. X, Y. We're going to pick our 5 favorite numbers in the world, except one of them is always 0. So we know we're going to pick 0. Tell me your favorite 2 positive numbers. 6 and 9. Still going with the big numbers. How about your 2 favorite negative numbers?
-5.
-5 and
-2.
-2. Very good. Again, the numbers you pick really doesn't matter. It's really up to you. As I say, most students will make it as easy as they can on themselves. They'll go 0, 1, and 2, -1 and -2. You don't have to pick those numbers though. If you want to use 0, 6, 9, -5, and -2, that's great. Plug in 0, tell me what you get.
5.
5, that's the easy one. Plug in 6, tell me what you get.
-13.
-13, anybody get a different answer? Negative what?
I was going to say -23.
-23?
No, that's fine.
But you're convinced you're wrong?
-13.
-13, we got -13 again. Any different answers?
For which one?
plugging in 6. Okay, so again, you got to watch your minus signs here. -3 times 6 is -18, and then -18 plus 5 is -13. You were correct. I was trying to talk you out of it. Couldn't do it. Plug in 9.
Negative 22.
-22, because when you plug in 9, -3 times 9 plus 5. -3 times 9.
27.
-27 plus 5.
20.
-22. Plugging in -5. 20, very good. -3 times -5. What happens when you multiply two negatives? Positive. So that's 15 plus 5, which is 20. Good. And finally, -3 times -2 is 6. 6 plus 5 is 11. Excellent. All right, so minus signs are probably the biggest mistakes that happen here. People will goof up their minuses, goof up their adding and subtracting, and things won't work out. So be very careful of your minus signs. Is there anything preventing you from using a calculator to do this?
No.
No. When you go to take a test, will I ever take your calculator away from you? No. You may use your calculator at all times. So if you need to use your calculator here, use your calculator. Okay? How do you want me to do scaling on the x-axis? See, that's the other advantage of always picking 0, 1, and 2, and -1 and -2. You always have to go 1, 2, 3, 4, 5. You don't have to think about it. What makes sense here? Threes. I think threes make sense. We'll go 3, 6, 9, -3, -6, -9. How about on the y-axis?
2.
Twos? Twos is going to be pretty, it's going to be a lot of them. Twos would work, but we've got to get all the way up to 20
Only 5.
and all the way down to -22. So if I go by twos, that means I'm going to need to draw 11 little tick marks. That'll work, but it's quite a few of them. I think I'd rather go by like 4s or 5s or something. That'd be a little easier. I'm going to go by 5s. 5, 10, 15, 20. Now, what's the disadvantage of going 5, 10, 15, 20? I'm going to have more estimations when I draw my dots. That's right. Which could lead to my dots not looking like they're in a line. So the more tick marks you draw, the better. But you got to balance that with, do I really want to draw 11 of them up and 10 of them down? That takes time. So I'm going to go by 5s. Okay, so 0, 5, there's our y-intercept. 6, -13. So here's 6, and that would be -15, so I got to go up just a little bit, right about there. 6, -13. 9, -22. 9, -20, just a little further. That looks good. They look like they're lined up still. -5, 20. All right, got to kind of guess here too. -5 is right about there. Up to 20. Still look like a line? Yep. All right, and then just for fun, I'm going to do this one wrong, because this is what's going to happen every now and then. Somebody is going to go 11, -2, and put a dot right there. What happens when you do that?
You don't have a line?
You don't have a line, so what should that tell you?
You did it wrong.
I did it wrong. And the nice thing is, you should be able to look at them and say, well, these 4 are right in a line, so which one is wrong? Got to be that one, right? Okay, so check for things like that. That's a very common mistake. People switch the x and the y. Don't do that. But if you do, it should be pretty obvious that it doesn't work. -2, 11. -2, 11. That looks better. Did it look like a nice straight line?
Yes.
Pretty close. This one looks like it's off a little bit, but it's not too bad. How come it looks like it's off a little bit? Couple of reasons. One, I'm estimating. 2, I don't really have a very good grid. My spacing here isn't exactly the same all the way. So I've estimated a couple different ways. Questions on that? All right, now I've got a hard one. Oh, on this one before we leave, just for fun. On this one we said our y-intercept was 0, 5. What's the x-intercept?
Negative 2 times not 2.
It looks like it's about 2.
Alright.
So you gotta kind of guess, do you? You can't tell exactly. I agree. It kind of looks like 2, but I don't think it really is 2.
1.5.
1.5. How come I don't think it's 2? What happens when I plug in 2? What's negative 3 times 2? It's negative 6. Negative 6 plus 5 is negative 1. So 2 is not quite the right answer, but it's close. Anybody know what the right answer actually is?
1.5.
1.5? Let's see, I'm going to grab my calculator. 1.5 times negative 3 is negative 4.5. Negative 4.5 is still a half. So again, you're closer, but I don't think that's right either.
1.
1. What's negative 3 times 1?
Negative 3.
Negative 3 plus 5?
2.
2. I'm supposed to get 0, so that's not right. So the moral of the story is it always easy to find the x-intercept?
No.
No. Is it easy to find the y-intercept?
Yeah.
Yes.
Yes. How do you find the y-intercept?
Small.
How do you find the y-intercept?
Alright.
Plug 0 in for the x number. Finding the y-intercept is always very, very easy. You plug 0 in for x. Finding the x-intercept is quite a bit harder. It turns out for this problem, the x-intercept is 5/3, 0.
Yep.
So you might have been guessing for a while before you came up with the answer of 5/3. Do I expect you to know how to find that at this point?
No.
No. We'll talk about how to do that later. There's a way I did that. Moral of the story is y-intercept is always easy. X-intercept is quite often difficult. Okay, let's try one more of these. How about y equals 1/2 x minus 2. Okay, this one I think it's a little bit harder. Why do I think this one is a little bit harder?
Fraction.
It's got fractions in it. What's wrong with fractions? They're a pain in the butt.
Can we turn it into a decimal?
You could, but I prefer if you didn't. Because if 1/2 happens to be a very nice decimal, happens to be 0.5, what if I'd given you 1/3 instead?
0.3.
0.3333 going forever. That's not such a nice decimal. So we're going to leave things as fractions. We're going to get used to fractions. We're going to deal with them. We're not going to ignore them.
So would you just turn the other one into fractions, put like a 1 underneath it? The other number?
What do you mean the other number?
2 over. I remember.
2 over 1?
Say when you're like plugging it in, would you just put the like a common denominator?
Yes.
Okay.
So when you have fractions, you have to be more clever about the numbers that you pick. We're not just going to pick our 5 favorite numbers at random here. So we'll see what to do. Same deal though. We're going to draw a table. We're going to pick our favorite number in the whole wide world.
0.
0. We still like 0 a lot. What's 1/2 times 0?
0.
0. 0 minus 2.
Negative 2.
Negative 2. Now, I do not, for this problem, want to pick the number 1. Why not? What's 1/2 times 1?
Because it comes out to decimal. It's like 1 round.
Yeah, 1/2 times 1 is still a fraction, or a decimal. And then when I subtract 2, I still get a fraction or a decimal. So I think I want to be more clever here. I don't want to pick 1.
2.
But I think 2 would be a good number to pick. Because, what's 1/2 times 2?
1.
Yeah, 1/2 times 2, the fraction goes away, doesn't it? 1/2 times 2 is 1. And then 1 minus 2? Negative 1. So when you have a fraction here, you have to be clever about the numbers that you pick. You want to pick numbers that make this fraction go away. What's another smart number to pick?
4.
4. Why 4? Why do we want even numbers for this problem?
For half, it's easier to get a half of an even than odd.
Because any even number I pick, I can half it, and I don't have any more fractions. So you're exactly right.
So say if there was like a 3, should you pick like things that are like that factor of 3, like?
Correct. If this was a 1/3, then you want to pick numbers like 3, 6, and 9. So that when you divide by 3, you get nice answers. What if this were a 1/5?
5, 10, 15, 20.
5, 10, 15, 20 would be the clever numbers to pick. Okay? So don't let the fractions freak you out. People see fractions and they say, oh, that's a fraction, I don't know how to do it. You can't do that in this class. We're going to have lots of fractions. You just got to be a little bit more clever. Pick the smart numbers. All right, so let's 1/2 times 4. 2. 2 minus 2. 0. That's something very important. What's that? That one happens to be the x-intercept because it's 4, 0. That's right on the x-axis. So sometimes you do get the x-intercept easy. Sometimes you don't. You always get the y-intercept easy. All right, how about your two favorite negative numbers?
-2 and -4.
-2 and -4. For the same reason, we want to pick numbers that make the fraction go away. -2 and -4. 1/2 times -2. -1 minus 2. -3. Excellent. And finally, 1/2 times -4. -2 minus 2. -4. And again, I can't emphasize this enough. There's absolutely nothing preventing you from using a calculator to do that. If you need a calculator, use it. Okay, get the right answers. All right, well, this time, I think I'm perfectly happy going 1, 2, 3, 4, and -1, -2, -3, -4, and also 1, 2, 3, 4 this direction, and -1, -2, -3, -4. My numbers are all pretty small. They all fit into that grid, so I'll use it. 0, -2. Where is 0, -2?
On the Y.
On the y-axis. That's our y-intercept. 0, -2. Right there. 2, -1. 2, -1. 4, 0. This time we happened, by accident, to find our x-intercept. That's nice when it works out that way. It doesn't always work out that way. -2, -3, and finally, -4, -4. They all line up very well. We connect the dots with a nice straight line. And things are good. Anybody have questions?